What we're going to cover today are the basics of the coordinate plane. All of this should really be a review, and the reason we're going through this is that it's the beginning of the unit on linear functions, and we're going to do a lot of work on graphing linear functions. So if we don't understand some of these basics, then we're going to have a little bit of a problem as we go forward. So let's get some definitions out of the way. Coordinate plane is a plane formed by the intersection of a horizontal number line and a vertical number line. The x-axis is the horizontal number line, and we have dealt with learning that by saying what's the horizon, where the sun sets or the sun rises. That's the horizon, horizontal. So then obviously the y-axis is the vertical number line. We learned to remember that because when you draw your little coordinate plane, if you put the y, you have the tail of the y coming down into the vertical line. The origin is the point which has a coordinate of 0, 0. And I'm just going to adjust my board here. In a coordinate plane, at which the x and y axes intersect. Now, as we've talked about before, the coordinate plane is broken into quadrants. Quad meaning 4, so it's one of 4 parts into which the axes divide the coordinate plane. Now, what's also important, and I'll draw this over here to the right, is that you know which axis, which quadrant is which. The first quadrant, upper right, and then the quadrants go counterclockwise. It's important to know which quadrant is which because you can be asked on a test where or what quadrant something lies in, and so that you need to know where each of the quadrants are. Ordered pair is each point in a coordinate plane corresponds to an ordered pair of real numbers. We're dealing with 2 dimensions, and they're written as x, comma, y. So the x-coordinate is the first number in an ordered pair. And then obviously the y-coordinate is the second number in an ordered pair. Okay. So now let's make sure we can figure out what each of the coordinates are. Now I'm going to write the coordinates right next to the points up here as opposed to down there, so it's a little bit easier to see. So the coordinate A, 1, 2, 3, 1, 2, 3, 4 is 3, 4. Coordinate B, I go 1, 2 to the right and 3 down, so that's 2, negative 3. Remember, here's my origin. Okay. Point C, I don't go right or left, so that means the x value is 0, and I went down 5, so 0, negative 5. Point D, I don't go up or down, so 1, 2, 3, 4, 5 to the left is negative 5. Since I don't go up and down, it's 0. And then E, 1, 2 to the left, and 1 up, so negative 2, comma 1. All right? The next example is to plot points when you're given the 5 coordinates. So let's plot these points. A is 5, negative 2, 1, 2, 3, 4, 5, 1, 2 down is A. B is 0, 3, so I don't go left or right, but I go up 3. C is negative 2, 0, so that means I go 2 left, but I don't go up or down, so that's C. Negative 6, 1 for D, 1, 2, 3, 4, 5, 6, and up 1. And 2, 7, 1, 2, and up 7 is E. Okay? And, oh, I'm sorry, D is a negative 1. Apologize for that. I was looking at this. I didn't see the minus sign. 4, 5, 6, and down. There we go. And there's D. Okay? Now, the last thing we want to deal with is distance. And I'm going to show you one example, what I'll call the long way, and then we'll figure out the easy way. I want to find the distance between 5 and negative 4, which is this point here, and 5, 10, which is this point here. So that's 5, 10, and 5, negative 4. Well, the simple way to count, or to figure out horizontal or vertical distance, is to count. So if I were to count the distance between these 2 points, you would see that there are 14 units in between. Well, I can do that for all of these, and if I were to scroll back up, and if you were to do that for each of these points, you'd find that this distance is 14, like we just did. The distance between 3, negative 4, and negative 1, oh, sorry, 3, negative 4, 1, 2, 3, and 1, negative 4 is a distance of 4 units. And if I do the same for the others, I get 9 and 4. Now, I could always do this counting, but I really don't want to have to do it if the points are very far apart. So there's a little formula. To figure out horizontal distance, I take the absolute value of the difference in the x's. Why absolute value? Because distance has to be positive. So to find the vertical distance, I take the absolute value of the difference in the y's. So if you go back up to what we just did, and the way to easily figure this out is you look at which one has a different x or y coordinate. So for example, looking at number 3 here, since the y coordinates are the same, it's going to be the x's that I'm going to subtract. And then in here, since the x's are the same, it's going to be the y's that I'm going to subtract. So negative 5 plus 1 is negative 4, which is 4. Okay? The last point is, what if I wanted to figure out diagonal distance? So in other words, let's say I have this little triangle here, and I have A, B, and C, and I want to figure out what the length of AC is. Well, I can't do my counting because I can't count distance of a diagonal. So what you would use there is what's called the Pythagorean theorem. Now, I mention this now, even though we're going to cover this later on in the course, only because I want you to understand that a diagonal distance is not something that can be obtained by the 2 formulas we talked about or by counting. Okay, so that today was the basics of the coordinate plane.